Hello everyone, welcome to this tutorial on the PySpark SQL isin function. In this video, we'll explore how you can easily check if a column's values exist in a predefined list using the isin function. Whether you're working with product categories, sales numbers, or any other dataset, isin allows you to filter rows based on specific values with minimal effort. This function is a great way to streamline your data filtering process and make your code more efficient. Let's jump in and see how it works. Introduction to the isin function. The isin function in PySpark is a powerful tool used to determine whether a column's value exists within a specified list of values. This function works similarly to the SQL in clause, allowing you to easily filter rows where the value in a particular column matches any of the values in a predefined list. By checking whether a column's value is part of this list, you can quickly identify relevant rows without needing to manually compare each value. This is especially useful when you need to categorize or filter data based on a set of known options or categories. For example, you might want to select all rows where a product falls into a certain group of categories, or where a customer belongs to a specific region or country. The isin function simplifies this process by allowing you to perform the check in a single function call. By using isin, you can make your data filtering more efficient and readable, particularly when working with large data sets. It's a great way to match column values against predefined lists or categories, making it a go-to function for situations where you need to check membership in a set of values. Basic syntax. The basic syntax for using the isin function in PySpark is dataframe.filterColumn.isinList underscore of underscore values. This syntax allows you to filter rows in a data frame where the values in a specified column match any value in the provided list. The column parameter represents the column you want to check, while the list underscore of underscore values is the set of values you're using to compare against the column's entries. When you apply this filter, the isin function will evaluate each row and keep only the rows where the column's value is found in the list. This makes it particularly useful when you need to filter data based on a fixed set of categories, such as products, regions, or status codes. For instance, if you have a column with product names and you want to filter out only specific products from a given list, you can use the isin function to check if the product's name matches any of the values in your predefined list. This approach is not only efficient but also keeps your code clean and readable by simplifying the filtering process to a single function call. This function works seamlessly for comparing against multiple values, making it a great option for filtering large datasets based on membership in a set of predefined values. Why use isin function? The isin function in PySpark is a highly effective tool for simplifying the process of filtering rows based on a set of predefined values. Instead of writing complex or repetitive code by chaining multiple equality conditions to check whether a column's value matches a series of options, isin allows you to perform this check in a single, concise function call. This is particularly useful when you need to filter data based on specific categories, IDs, or other criteria that involve multiple values. Using isin improves both the efficiency and readability of your code, especially when working with large datasets or multiple values. Rather than manually comparing each value one by one, you can pass a list of values directly into the function and it will check if any of the values in the column match the ones in your list. This makes it much easier to manage and maintain your filtering logic, particularly when dealing with datasets that require frequent filtering based on various categories or identifiers. Practical examples. 1. Filtering rows based on a list of values. In this example, we are using the isin function in PySpark to filter rows based on the values in the product underscore name column. The data frame df contains two columns, product underscore name and sales, with values representing product names, names, product names, and their corresponding sales figures. Our goal is to filter the data frame to keep only the rows where the product underscore name is either product A or product C. To achieve this, we use the filter method along with the isin function. The isin function is applied to the product underscore name column, and it checks whether the product name matches any of the values in the given list, product A and product C in this case. If a product name matches one of these values, the row is kept in the filtered data frame. When we display the result using the show method, the output includes only the rows for product A and product C, while product B is excluded since it is not part of the specified list. This example demonstrates how the isin function allows you to filter rows efficiently based on a predefined set of values. By using isin, you can quickly identify and retain rows that match specific criteria, making the filtering process more concise and readable, especially when working with multiple values or categories. 2. Using a Python list with isin. In this example, we are using the isin function in PySpark in combination with a Python list to filter rows based on the values in the product underscore name column. The data frame df contains two columns, product underscore name and sales, representing different products and their corresponding sales figures. We aim to filter the data frame and keep only the rows where the product underscore name matches specific values defined in a Python list. First, we define a Python list called product underscore list, which contains the values product A and product C. This list represents the products we want to keep in the filter data frame. Next, we use the filter method along with the isin function to check whether the values in the product underscore name column are present in the product underscore list. If a product name is in the list, the corresponding row is retained. The result is displayed using the show method, and it includes only the rows for product A and product C, as these are the product names listed in the product underscore list. Product B is excluded because it is not part of the specified list. This approach demonstrates how the isin function can be combined with a Python list to filter rows dynamically based on external input. By passing a list to the isin function, you can make your filtering logic more flexible and adaptable, especially when working with dynamic or predefined lists of values. This technique is useful when you want to filter data based on a set of categories or identifiers that are stored outside the data frame, such as in a Python list. 3. Combining isin with other filters. In this example, we are combining the isin function with an additional condition to filter rows based on both the product name and the sales values in a PySpark data frame. The data frame df contains two columns, product underscore name and sales, representing various products and their sales figures. Our goal is to filter the data frame and keep only the rows where the product underscore name matches either product A or product C, and where the sales value is greater than 400. To achieve this, we use the filter method along with the isin function and a second condition df.sales400. The isin function checks whether the product underscore name is either product A or product C. And the additional condition df.sales400 ensures that only rows with sales greater than 400 are retained. The two conditions are combined using the AND operator, meaning that both conditions must be true for a row to be included in the result. When the filter data frame is displayed using the show method, we see that only the row for product C is retained. Although product A is in the list of product names, its sales value is 500, which meets the condition. Product B is excluded because it doesn't match the product names, and product C is kept because it meets both conditions. It is in the list of products and has a sales value of 700, which is greater than 400. This example demonstrates how you can combine the isin function with additional conditions to perform more complex filtering operations. By using logical operators, like you can build flexible queries that filter data based on multiple criteria, making it easier to analyze or process data based on specific requirements. 4. Using isin with multiple columns. In this example, we are using the isin function in PySpark to filter rows based on two different columns, product underscore name and category, each matched against a separate list of values. The data frame df underscore multi contains three columns, product underscore name, category, and sales, representing different products, their categories, and sales figures. Our goal is to filter the data frame and keep only the rows where both the product underscore name and category match specific values from predefined lists. We achieve this by applying the filter method with two isin functions, one for the product underscore name column and another for the category column. The first isin function checks whether the product name is either product A or product E or product C. The second isin function checks whether the category is category 1. Both conditions are combined using the AND operator, meaning that both the product name and category must match the respective list for a row to be included in the result. When the filtered data frame is displayed using the show method, only the rows that match both conditions are retained. In this case, the rows for product A and product C are kept because they both belong to category 1. Product B is excluded because its category does not match category 1, even though it is part of the data frame. This example demonstrates how you can use the isin function to filter data based on multiple columns, each with its own set of criteria. By applying the operator to combine these conditions, you can build flexible and complex queries that allow for filtering based on more than one column simultaneously, making it an efficient way to match data across different categories or lists. With 5. Using isin to filter numeric columns. In this example, we are using the isin function in PySpark to filter rows based on specific values in the sales column. The data frame df contains two columns, product underscore name and sales, with sales figures associated with each product. Our goal is to filter the data frame and retain only the rows where the sales value matches one of the predefined values, in this case 300 or 500. To accomplish this, we use the filter method along with the isin function. The isin function is applied to the sales column and it checks whether the sales value matches either 300 or 500. If a row sales value is one of these numbers, the row is included in the filtered data frame, otherwise it is excluded. When the result is displayed using the show method, the output includes only the rows where the sales values are 300 or 500. Any rows with sales values that do not match this criteria, such as sales of 700, are excluded. This example demonstrates how the isin function can be effectively used to filter rows based on numeric values. It allows you to quickly match a column's values against the list of specific numbers, making it useful for filtering data based on predefined thresholds or categories. This approach is especially efficient when working with large data sets or when filtering based on multiple possible values. 6. Handling null values in isin. In this example, we are using the isin function in PySpark to filter rows based on values in the sales column while also handling null values. The data frame df underscore with underscore nulls contains two columns, product underscore name and sales, with some rows having valid sales figures and one row having a null missing value in the sales column. Our goal is to filter the data frame to keep only the rows where the sales value is either 500 or 700, and we need to ensure that the null values is handled properly. To achieve this, we use the filter method along with the isin function, applying it to the sales column. The isin function checks whether the sales value matches any of the specified values minus 500 or 700 in this case. Rows where the sales value is either 500 or 700 are kept, while rows with other values or null values are excluded. When the filter data frame is displayed using the show method, we see that the rows for product A and product C are retained because their sales values match the specified numbers. The row for product B, which has a null value in the sales column, is excluded because null values are not considered in the isin function unless explicitly handled. This example demonstrates how the isin function can be used to filter rows based on specific numeric values while also handling null values gracefully. If nulls are present in the dataset, they will be automatically excluded unless additional logic is added to handle them specifically. This makes isin a convenient tool for filtering data based on a predefined list of values, ensuring that the filtering process is both efficient and accurate. That wraps up our tutorial on using the isin function in PySpark SQL. As you've seen, this function simplifies filtering rows by checking if values exist in a list, making it perfect for data analysis tasks. Whether you're filtering by categories, IDs, or numeric ranges, isin is a powerful tool to have in your PySpark toolkit. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more PySpark tutorials. Thanks for watching and see you in the next video.